Hello everyone. In this lecture, we are going to discuss about the derivation of Rodrigue's formula. It is an important formula in Legendre polynomial. Now, as per the Rodrigue's formula, P and X is equal to 1 over 2 to the power n factorial n time differentiation of x square minus 1 to the power n with respect to x. So this is the Rodrigue's formula. We have to prove this. To prove this, we assume let v is equal to x square minus 1 to the power n. That means we assume this portion as a v. Now differentiating this equation 1 with respect to x, we get dv by dx is equal to n x square minus 1 to the power n minus 1 into 2x. Now multiplying both sides, by x square minus 1, we get x square minus 1 dv by dx is equal to 2n x square minus 1 to the power n x. That means when we simplify it, we get x square minus 1 dv by dx is equal to 2n vx, because this value is assumed as v previously, so it is replaced by v over here. Now we get a differential equation. Now differentiating this, differentiating equation 2. Now this is equation 2. N plus 1 times. Now we have to differentiate n plus 1 times. So we have one formula, that is Leibniz that is Leibniz theorem. So we implement it. For this is first, this is second, and over here 2n is constant. This is first and this is second. So we get the value x square minus 1 dn plus 2 over dx to the power n plus 2 of v plus n plus 1 c1 into 2x into d n plus 1 by dx to the power n plus 1 of v plus n plus 1 c2 d n v over dx to the power n, means n time derivative, is equal to 2n is constant on the left side, and for the remaining term x is constant, n time differentiation, n plus 1 time differentiation with respect to x of v plus n plus 1 c1, and differentiation of x is 1, and dn v over dx to the power n, means derivative of v with respect to n twice. Now when we simplify it, the right side portion we have to take it on the left side. We get x square minus 1 dn plus 2 over dx to the power n plus 2 of v plus 2x n plus 1 c1 minus n dn plus 1 dx to the power n plus 1 v. This n is from the right side, from this side, plus 2 into n plus 1 c2 minus n plus 1 c1 and the derivative nv over dx to the power n is equal to 0. Now finally we have an equation, that is x square minus 1 n plus 2 times derivative of v with respect to x plus 2x dn plus 1 over dx to the power n plus 1 v minus n plus 1 n time differentiation of v with respect to x is equal to 0. Now we get this equation. Now if we assume dnv over dx to the power n is equal to y in the previous equation, then we have x square minus 1 d square y over dx square plus 2x dy over dx minus n plus 1 y is equal to 0. Now taking the 1 minus 1 as a common, then we have 1 minus x square d square y by dx square minus 2x dy by dx plus n plus 1 y is equal to 0. Now as we know that this is the Legendre equation, so if this is the Legendre equation, then it must have a solution as a Legendre solution. So the solution of this equation, equation B, is y is equal to dny by dx square, and this value is equal to d square v over dx square, this value is equal to n time derivative of v with respect to x, actually this is equal to y, is equal to p and x, arbitrary constant, into p and x. So we assume an arbitrary constant as 1 by c p and x. That means finally we have p and x, Legendre polynomial, is equal to c into n time differentiation of v with respect to x. That means this is the value of y. This is the value of y. So this is p and x is equal to c into y. Now if we have this, then again we have v is equal to x square minus 1 to the power n. Now by using the formula a square minus b square, we can split it as x plus 1 to the power n and x minus 1 to the power n as a v. So this is equation C. Now equation D. Now we use Leibniz theorem to differentiate and find the value of n time derivative of v with respect to x. Now over here we have to remember this term as a first and this term as a second. So we have, by using Leibniz theorem, first is same, x plus 1 is same. For second derivative of n time, that means n time differentiation with respect to x of n of x minus 1 to the power n. Next term will be differentiation of this x plus 1 is nc1. Next term will be nc1 into n x plus 1 to the power n minus 1 single time differentiation, and n minus 1 time differentiation with respect to n minus 1 for x minus 1 to the power n, and so on. Now this is equation E. Now if we take x is equal to 1 in equation E, we get d and v over dx to the power n is equal to, now when we substitute the value over here, we find this is equal to x plus 1, that will be 2 to the power, sorry it's simple 2, and n time differentiation of x minus 1 to the power n will be factorial of n. So this is the nth derivative value when x is equal to 1 for v. Now by using equation A, B, C, E, F, by using equation F and this value, we get P n 1 is equal to 2 to the power 2 into factorial n into c. So when value is 1 and Pn1 is 1, we know that the value of Pn1 is always 1. So we substitute this value and we find that the value of C is equal to 1 by 2 to the power n factorial n. We have the value of C, we have this main equation, and substitute this value over here, we get Pnx is equal to C into d and v over dx to the power n. Now we substitute the value of C as well as v. So Pnx is equal to 1 over 2 into factorial n and n time differentiation with respect to x of v, and the value of v is x square minus 1 to the power n. Now over here we prove the Rodrigue's formula. It is the important formula in Legendre polynomial. So please do it and practice it. If you have any doubt and any query, feel free to contact your concerned class faculty. Thank you. For any doubt and any query, feel free to contact your concerned faculty. And for upcoming videos, subscribe this channel. Stay home, stay safe.